Hi everyone, my name's Chris Smith. I'm the technology manager here at FAR, as David's told you all. Today I'm going to talk about the current and future role of precision ag in maize systems in New Zealand. I will basically I'll start off looking at the current precision ag technologies used, then sort of briefly go over some of the potential future roles of precision ag in maize, and then roll back to where to start if you wanted to get on this journey and what the benefits are. And at the end, we take some questions. So I'll quickly just give you an overview of the precision ag technologies used currently in the maize systems in New Zealand, and then I'll go into a bit more detail on a few of these. So at the moment, we have GPS guidance, that's for positioning your tractors, etc. It's quite commonly used in New Zealand with auto steer, boom controls. And we have nutrient mappings, that could be grid or zonal soil sampling, which is generally used for your base nutrients, variable rates, and also lime. That's quite commonly used throughout New Zealand. And then a bit more specialist, but still quite commonly used, is soil texture mappings. That can be EM or EC mapping. That's used for variable rate planting, but predominantly it's used for moisture management and creating zones within your paddock. So you can actually use those and manage those in different ways. And then we have sort of soil and moisture sensors, weather systems. So we have the FAR weather platform. A lot of people use that. We have moisture probes for looking at soil temperatures and soil moistures and when the crop's getting at stress levels. And these different platforms can help with decision tools and decision making throughout the season. And another area that's used quite commonly is imagery, be that satellite or drone imagery for variable rate nutrients, canopy, crop development, looking at your crop throughout the season and making management decisions on what's happened within your crop within the season and how that's affected the actual biomass of the crop. Finally, quite commonly used is yield mapping, whether that be sort of from forage harvesters or the grain combine harvesters, looking at the yield quality and variations in quantity, quality, etc., and where your high points, low points were, and also doing post-harvest reviews of what you've tried that year and how it actually impacted on your final yield. So I'll now talk a bit more detail about a few of these different precision ag technologies used in New Zealand. So firstly, I'll look about nutrient mapping. Basically, it's quantifying your soil characteristics. That can be physical, chemical, or biological, depending on what you pay for, what you want. Most people just do the basic soil analysis for your sort of P, K, magnesium, pH, etc. And once you determine the levels and you know the target levels for the crop requirements, you can then put the right amount of fertilizer in the right place at the right time. This can be done, as I said, zonally or grid sampling. So what is grid sampling? Grid sampling is where you take a multiple amount of points from within a paddock. Each one of those red dots will be a georeference point. And then from that point, you then take 15 core samples and make a composite sample. That's then sent off to the laboratory. The laboratory send the results back, and then the results are tied to each of those individual points. And then you create the spatial maps for all your different nutrients. All these points, like I said, are georeference, which means you can return to them in a 5 year sort of rotation if you need be, and you can actually see what you've applied over the last 5 years and what you've actually taken off from the crop and see what your nitrogen and what your nutrient efficiencies are like. So it's very sort of repeatable process, which is what it feels to a lot of people. It's very valuable as well when you have lots of different crops or areas of a paddock merged into one. If you've got different cropping histories with different nutrient loadings, it's a great way of trying to balance out your paddocks without putting a blanket rate on. Another form of soil sampling, it's lesser resolution, is zonal soil sampling. So what you need for zonal soil sampling is different maps that showing you the same sort of zones, etc. That be yield maps, EM maps, or biomass maps. If they're all showing you the same sort of zones, you can then take samples within those zones. So it's more cost effective than grid soil sampling because it's on a lower resolution than the 1 per hectare of soil sampling, grid sampling. So, but you still end up getting the variable rate capability. These sort of zonal maps can also be used for planting as well. Quite often, people are using it for that as well. So here we have a example. This was a pH. This was a pH map. The target pH for the grower was a pH of 6. So what he did was anything that was pH 6 or above is in blue and had no lime. And as you went down the paddock, different areas, what they had a sort of 1 ton per 0.1 pH unit. They wanted to increase the pH up to 6. So they worked out that for the variable rate map. They also did a whole paddock test, and the whole paddock test came out at 5.7. So to hit his target of a pH of 6, if he had done blanket rate, he would have put 3 tons a hectare across the whole paddock, which would have equated to about 45 tons of total lime. But by using variable rate, he only had to use 9 tons. So he had a saving of about 35 tons, and which equated to about $86 a hectare saving, which more than paid for all the grid sampling for that season for that paddock. But it's very much each different sort of paddock is its own, and the variability does actually dictate how much money you get back from that. So this is just sort of a guide, really, just to show you money that can be saved. Another area where a lot of people do work is with the EC and EM mapping. So this basically quantifies the soil texture going across your paddock. It works on the premise that clay has a higher sort of EM or EC reading than silt, that in turn has a higher reading than sand. So as you're going across the paddock, you're going in a 12-meter swaths, and you're picking up the variation. So you can see in the map on the right-hand side there, where we've got red areas which indicate lighter soils through to greens and blues which are heavier soils. So you're seeing the variability. This is our NCRS site up in Waikato. So you can see the great variation here, the different soil types. It's a great surrogate for our water holding capacity. These maps are all geo-referenced, so you could actually go in there with a neutron probe and ground truth the map to find out what your water holding capacity is of these different areas. And probably the greatest gains from EM and EC is from water management, but it's also a great indication of yield potential in dryland situations. David and the team have done some trials as a 5-year project on for variable rate planting. I'm sure David's spoken about this already, with changing the hybrids for the populations depending on the soil types, etc. So I won't go too much detail of this. I know David's spoken on this, but basically putting offensive hybrids with sort of more aggressive sort of traits, sort of high yielding traits on the better soils, and on the sort of lighter, sandier soils, putting defensive hybrids with sort of more drought tolerant on those areas. And we also changed the populations as well, but I won't get, like I say, David's spoken about this, but it's just showing you another example of how EM mapping can be used in the maize industry. We've got on to aerial imagery. There's a couple of sources of aerial imagery that are commonly used for precision ag. There's satellite imagery. This is generally cheaper on a larger scale. You can actually click on several of your paddocks within that, and it'll bring them all up, and you can look at all the different maps against each other. All the layers are calibrated, whichever system you're looking at, and so you can actually compare one paddock with another quite easily. The downside of it is it's generally, depending on what image you're looking at, the cheap sort of imagery is about 10 meter pixels, and some of the layers can actually be 20 meter pixels. So it's a very low resolution. And also cloud cover can be the Achilles heel of satellite imagery. You can be waiting a long time for an image to turn up, and there could be quite a big gap between the different images. In that sort of situation, the drone imagery can be a lot more useful as it's cloud proof. It does require calibration, and because it's only done on individual paddocks, it can work out more expensive. And it's recommended that you actually get somebody to do the imagery and process it, who actually does it as a service. That way you'll get a more efficient and a better sort of clear data. The files can be quite large as well, so it can be issues with transferring projects and folders, etc. Aerial imagery has got a lot of uses, especially the multispectral imagery. There's different layers, there's sort of water stress layers, there's chlorophyll layers. They can all be used for different things. So it's about using the right layer, and they're all at different resolutions as well. Like I say, some are 10 meter pixels, some are 20 meter pixels. So it's finding the right layer for your needs. You can see crop health and stress. Like I say, it depends on the resolution. Aerial imagery can be used for yield estimates and sort of from your biomass near harvest, and also where to take your samples for harvest as well, so you can look at the different sort of densities of the crop and decide where to go to taking your sampling. It can be used for variable rate nutrients, but definitely needs ground truthing. Don't just presume that a paddock needs more nitrogen in certain areas. There may be a feast of other reasons why it needs that, and including weeds, pests, and diseases might be affecting it. So it's a great way of actually going out to a paddock, fly the drone over, see what's the differences are in the crop, and actually go to those areas of interest rather than just randomly walking through the paddock. It can be used for creating planting maps as well, and it's also a great decision tool from looking at different decisions you've taken on farm and working out whether they were good or bad. This leads quite nicely onto the next slide, which is from Chris Pellows. Thanks, Chris, and for letting us use this. So Chris is a 8-row planter. He had 4 rows of one hybrid in 4 boxes and 4 rows of the other hybrid in the other 4 boxes on his planter. So as he was going up and down the paddock, he was effectively putting 8 rows of each of the hybrids out as he was sowing. And then David came in with his drone, and back in September and February, in quite a drought year, he sort of flew the paddock, and you could see the striping coming through from the 2 different hybrids, which is quite interesting. And it's basically, you can see one hybrid outperform the other. And then from the yield maps themselves as well, you can see again the stripings coming through from the 2 different hybrids, which is a great way of Chris used this for his hybrid selection for the following season. So you can see it's just another way of making management decisions off your satellite imagery. Another imagery sort of project with Paul Hunter. Paul's talked about this already, so I won't go too much detail of this, but basically from imagery that him and David collected, they actually did plant populations from 85,000 up to 115,000 in the blue zones. They're changing the plant population based on historic imagery, and then they've run the trial from two fixed different nitrogen rates versus variable rate as well on that site. But like I say, I know Paul's been talking about this already, so I won't sort of dwell on that for too much. So yield mapping is the last big area of where precision ag can be used, whether it's the contractor or the grower themselves, whether it's for silage or for actually corn for grain itself. It quantifies your variability and the quality across your paddocks, and it gives you areas to actually identify, okay, one area is high, one area is low. Why is that? What's causing that difference? And it's a one-off opportunity to collect this data. You can collect drone data near the time of harvest, but it never really quantifies your dry matter exactly the same, or your tons per hectare, as sticking the machine through and actually recording that data. The more years worth of data you've got, the more powerful it becomes. So this means by sort of taking 1 year's data, it depends on what the season was like for where your high yielding and low yielding areas were, but by collecting multiple years worth of data, you pick up a picture of where is consistently lower yielding and where's consistently higher yielding. So this way you can actually go and investigate what's causing that and see what's happening there. It might be a case that you've got a yield cap on a certain area and you can't push it past that point, in which case then you can reduce your inputs accordingly. Yield mapping on the forage harvesters can also actually be used as part of the maize forage trading protocol with the NRI sensor technology. So this is just another use that's quite unique to the forage industry. With the protocol, the sensors continuously measures the forage biomass as you're going across the, sorry, not biomass, the dry matter. And on tests we've actually done, the results from the NRI were less than 3% difference from the actual lab tests. So this helps growers actually replace the stack and truck protocols and makes it a lot more sort of quantifiable, so you can see the range within your paddock of the differences. At the moment, it's the John Deere Harvest Lab and the Class Jaguar NRI systems that have been approved for this type of mapping, but both parties taking part in the actual sort of protocol and the trade themselves, both must agree to use the NRI, obviously, for it to actually be used as a viable sort of form of the actual agreement. So looking at future roles of precision ag in maize systems.
Chris, just a couple of minutes, Chris.
Yeah, okay, I'll better speed up a bit. Sorry about that. Looking at the future roles of precision ag, We've got robots and automation. So here at the top there, you've got the earth sensor, and what it's doing, it's going up and down the rows of maize, and it's looking at the stem width, the area, leaf index, plant height to ear, etc., and doing stand counts throughout the season. And then below that, you've got a farm bot with a sprayer on the bottom with doing what it's doing is green on brown spraying. So it's spraying a stubble paddock. It's only spraying weeds when it sees them and nothing else. It's completely autonomous. So it unfolds, goes to the paddock, drives around the paddock, does the whole paddock. We'll go around telegraph poles, etc. When it's finished, we'll fold up and move on to the next paddock. If it gets too windy, it will stop, wait for the wind to drop and carry on again. So this is what's happening in sort of Australia and other places. There's also a lot of work being going on to machine learning and AI. So every time you're going over the paddock, we can see there's going to be a lot more data collected that's not actually used at the time, but just help for future applications, etc. So here we've got the agronomist on the left, top and bottom picture, who picked out the weeds, and then there's artificial intelligence on the right that's also picked out the weeds. So you can see that's going to be getting to the point where we'll be able to do real life as applied maps going forward. And also there's different work and technologies going on with lasers and electricity for a weed control rather than depending on chemicals. Better use of sensors. They've been from going from the sort of low resolution 20-meter pixels, we'll be going to the higher resolution imagery. So it'll be higher resolution, greater reliability. We won't be worrying about cloud cover. You'll get more frequent, better quality imageries coming through, but the data size will become a lot larger. So we're going to have to manage that data a lot more. There's going to be a lot more information coming into the farm as well, which could be a challenge. So we're looking at defining the data at different scales. Traditionally, we've gone at field rates. At the moment, we're at sort of variable rates. So we're looking at sort of zones within the different paddocks. But moving forward, we're going to be looking at single plant management. And then from that, we could even go down to leaf scale management. But that's got to show a return and make it more viable, make it more accurate. And there'll be a lot more data integration and better sort of interpretation of this data automatically. So it might just come through on your phone, but there'll be a lot of number crunching going on in the background with AI and machine learning. And hopefully we'll get better interoperability between the different systems. So quickly looking at where to start if you wanted to go down precision ag road. Like I say, yield mapping and satellite imagery quantify your variability. It helps you investigate the drivers behind that variability, and also you can see the effects of your management decisions. The contractors will generally have yield mapping on their machines, or if they don't have that, you can use satellite imagery. GPS guidance, auto steer makes operations a lot more efficient, and boom control will also help make the most of your inputs by not over applying and under applying. And then finally, nutrient sample mapping can be used because you have the consultants that can help you, and there's contractors out there who've now got variable rate capability, so you don't need to have this kit yourself. You can actually take the advantages from it without having to have it yourself. So it's quite an easy entry level into precision ag. And just my last slide. Sorry, David. This is just from the SFF project, looking at transforming variability to profitability. On the table, we have sort of technologies down the left-hand side, then the yield benefit as a percentage, the input savings in the third column, and then the return on investment, which has been based off the silage production costs from 2023, 2024, and using the forage and grain prices there on the bottom right as well. So you can see from auto steer, by driving accurately, you're making a sort of 3 to 7% saving depending on the accuracy of your auto steer. Planters, you're getting the sort of 4 to 7% increase, which is a good saving up to about $55 a hectare. Accurate flat rate application, that's from calibrating your sprayer, driving in straight lines with auto steer, and having border and sort of headland controls can make quite significant saving as well. And then variable rate on top of that can give you additional savings on your inputs as well as yield benefits. But that does depend on the amount of variability on how much you'll save. And then nitrogen fertilizer is mainly on the yield benefit. You can actually end up putting more on, but you're getting more efficient use of your nitrogen. And then I say, we've spoken before briefly, boom controllers on sprayers can give you an input saving by not overlapping, etc. And then if you look at the overall costs, like I say, it probably comes on return on investment, comes in dependent on the variability. the cost of your inputs, obviously, and the value of your crop to how much money it's worth. But looking at these different figures, if you'd be looking between $500 and about $1,000 per hectare return on investment, depending on which up to that, obviously, if you did all those different factors. But that gives you a good idea if there is opportunities out there to actually do something in the precision ag space.
Now look, carry on. You're right.
I'd say that's my email at the bottom. So if I'm not there, apologies for not being there today, but anybody wants to get in touch with me and talk about any of this further, there's my contact detail at the bottom there.
No, good stuff, Chris. Hey, just 1 second, Chris, just stay there. For our next speakers, can they get mic'd up or are they already mic'd up? All done. All right, very good. Hey, Chris, just before I open up for questions, in the future, can you change the pull-up banner in the background, please? This is a maize conference you're speaking at.
Yeah, sorry, David. Yeah, I'll put a big maize cob in the background.
Oh, Anna's saying you're excused, Chris, because it's up here, so it's all good. We need two. Okay, so quick questions from the room for Chris. I think that's a no, Chris. Either they're not sure about your presentation or you've answered all their questions, but precision ag is one of those things we've been talking about forever, but at last it is growing momentum. So I'm pleased to say. Hey, Chris, thanks for that. That was an awesome presentation. Bringing it to New Zealand. Can I ask everybody to put their hands together for Chris? Thank you.